Understanding the Hybrid Connectivity Challenge. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with a focus on networking. Today we're analyzing a complex GCP networking exam question. Let me read the complete scenario. Let's say you're the network engineer in a small firm. You are tasked with implementing a cost-effective hybrid connectivity that can serve up to 4.5 gigabits per second between GCP and the on-premises networks. The GCP VPC will have subnets with resources in several regions. You have the requirements below. The requirements listed are: speed of delivery and low cost. Dynamically advertise all subnets in the VPC to the on-premises network. And encrypted communications between GCP and the on-premises network. Then the question asks, which of the following would you configure in GCP? We have 4 options to evaluate. Option 1. Create a VPC with a global dynamic routing mode and subnets in the desired regions. Create a cloud router in any region with a subnet and create cloud VPN with 2 tunnels in the region of the cloud router. Option 2. Create a VPC with a default dynamic routing mode and subnets in the desired regions. Create cloud VPN with 2 tunnels in the region of the cloud router. Option 3. Create a VPC with a global dynamic routing mode and subnets in the desired regions. Create a cloud router in any region with a subnet and create cloud VPN with 1 tunnel in the region of the cloud router. Option 4. Create a VPC with a default dynamic routing mode and subnets in the desired regions. Create a cloud router in any region with a subnet and create cloud VPN with 2 tunnels in the region of the cloud router. Create a route to the on-premises network with the next hop as the VPN tunnels. This question tests multiple concepts: VPN bandwidth limitations, global versus regional routing modes, and how to architect a cost-effective solution for multi-region deployments. Let's analyze each option systematically. Analyzing Cloud VPN bandwidth capabilities. Before we dive into the specific options, let's understand a critical technical detail about Cloud VPN in GCP. A single Cloud VPN tunnel can provide up to 3 gigabits per second of bandwidth. This is a hard limit per tunnel. However, you can create multiple tunnels and use ECMP routing to aggregate bandwidth. With 2 tunnels, you can achieve up to 6 gigabits per second of aggregated bandwidth, which exceeds our 4.5 gigabits per second requirement. This is why you'll notice that most options mention 2 tunnels. It's the minimum needed to meet the bandwidth requirement. Using more tunnels would work, but it increases cost unnecessarily. Cloud VPN uses IPsec for encryption, which satisfies our security requirement. It also supports BGP for dynamic routing, allowing us to automatically advertise all VPC subnets to the on-premises network. The cost is relatively low compared to dedicated interconnects, making it suitable for a small firm. Now, the critical decision point becomes: should we use global or regional routing mode for our VPC? And where should we place our cloud router? This decision significantly impacts our architecture's flexibility and cost. Understanding the difference between global and regional dynamic routing modes is crucial for this question. In regional mode, cloud routers only advertise routes from subnets in the same region. For example, if you have subnets in ES Central 1, Europe West 1, and Asia East 1, a cloud router in ES Central 1 with regional mode will only advertise the ES Central 1 subnets to your on-premises network. In global dynamic routing mode, any cloud router in your VPC advertises routes from all regions. This means a single cloud router in ES Central 1 can advertise subnets from all regions to your on-premises network. This is exactly what we need based on the requirement to dynamically advertise all subnets in the VPC to the on-premises network. The key advantage of global mode for our scenario is that we only need 1 cloud router, not multiple routers in each region. This reduces complexity and cost. Remember, We're a small firm looking for a cost-effective solution. Multiple cloud routers mean multiple configurations, multiple BGP sessions, and potentially multiple VPN connections. Let's look at how this impacts our architecture and why it makes certain options more suitable than others. Examining option 1. Global mode with cloud router in any region. The first option suggests creating a VPC with global dynamic routing mode, subnets in desired regions, a cloud router in any region with a subnet, and a cloud VPN with 2 tunnels in the region of the cloud router. This is a very good solution that meets all our requirements. With global routing mode, the cloud router can be placed in any region that has a subnet, and it will advertise routes from all regions to the on-premises network. The 2 VPN tunnels provide up to 6 gigabits per second of aggregated bandwidth, exceeding our 4.5 gigabits per second requirement. The solution is cost-effective because we only need 1 cloud router and 1 VPN gateway. However, there is a subtle consideration here. The phrase "any region with a subnet" suggests flexibility in placement, but in practice, you would want to place the cloud router in a region that is geographically close to your on-premises data center to minimize latency. The VPN tunnels would terminate in the same region as the cloud router. This option would work well and meet all requirements. It is a valid solution that many organizations use successfully. Let's examine option 2, which proposes a default mode with 2 tunnels. This option uses the default dynamic routing mode, which is regional, along with subnets in the desired regions and a cloud VPN with 2 tunnels in the cloud router's region. The critical issue here is the use of the default, regional routing mode. In this mode, the cloud router will only advertise subnets from its own region. If you have subnets in multiple regions, as the scenario states, the subnets in those other regions won't be advertised to the on-premises network. This fails to meet the requirement to dynamically advertise all subnets in the VPC to the on-premises network. You might think you could work around this by creating custom static routes, but that would defeat the purpose of dynamic routing and add operational complexity. It also doesn't scale well as you add more subnets or regions. While this option provides sufficient bandwidth, with 2 tunnels providing up to 6 gigabits per second, and encryption, it fundamentally fails the dynamic routing requirement for a multi-region setup. This makes it unsuitable for our scenario. Examining option 3. Global mode with 1 tunnel. The third option uses global dynamic routing mode and correctly places the cloud router, but it only creates 1 VPN tunnel. This is where the bandwidth mathematics become critical. A single cloud VPN tunnel maxes out at 3 gigabits per second, but we need up to 4.5 gigabits per second. This option fails the fundamental bandwidth requirement. No amount of optimization or configuration can make a single tunnel exceed its 3 gigabits per second limit. You might achieve 3 gigabits per second with perfect conditions, but you'll never reach the required 4.5 gigabits per second. It's worth noting that everything else about this option is correct. The global routing mode ensures all subnets are advertised. The architecture is simple and cost-effective, and encryption is provided. But failing the bandwidth requirement makes this a non-starter. This option might be suitable for scenarios requiring less than 3 gigabits per second, but not for our specific requirements. It's a good reminder that in cloud architecture, you must meet all requirements, not just most of them. Examining option 4. Regional mode with static routes. The fourth option is interesting because it acknowledges the limitation of regional routing mode and attempts to work around it. It uses default regional routing mode but adds a static route to the on-premises network with the VPN tunnels as the next hop. However, this option has several problems. First, it talks about creating a route to the on-premises network, but the requirement is to advertise subnets from the VPC to on-premises, not the other way around. This suggests a misunderstanding of the routing direction. Second, even if we interpret this as creating static routes for each VPC subnet to be advertised to on-premises, this defeats the purpose of dynamic routing. You would need to manually create and maintain routes for every subnet in every region. This does not meet the dynamically advertised requirement. Third, using static routes instead of BGP means you lose the automatic failover and path selection benefits of dynamic routing. This reduces the solution's reliability and increases operational overhead, which is not ideal for a small firm with limited resources. Cost analysis and best practices. Let's analyze the cost implications of each option for a small firm. Cloud VPN pricing includes an hourly charge for the VPN gateway, at about 5 cents per hour, and a per tunnel charge. Cloud Router itself is free, but you pay for the VPN tunnels it manages. Option 1. Using global mode with 2 tunnels, costs approximately $108 per month. This breaks down into 1 VPN gateway for $36 per month, plus 2 tunnels for $72 per month. This is very cost-effective for 4.5 gigabits per second of encrypted connectivity. Compare this to dedicated interconnect options. A 10 gigabits per second interconnect can cost thousands of dollars per month, plus cross-connect fees. For a small firm needing only 4.5 gigabits per second, Cloud VPN is much more economical. Best practices for this setup include using IKEv2 for better performance, configuring both tunnels for active-active ECMP routing, monitoring tunnel utilization to ensure traffic is balanced, setting up cloud monitoring alerts for tunnel failures, and documenting the BGP configuration for troubleshooting. Remember that while we need 2 tunnels for bandwidth, having exactly 2 also provides redundancy. If one tunnel fails, you still have 3 gigabits per second of capacity while you troubleshoot. Let's walk through the actual implementation of the correct solution. First, you'll create your VPC with Global Dynamic Routing Mode using the command G-Cloud Compute Networks create my VPC subnet mode custom BGP routing mode global. The global BGP routing mode is crucial here. Next, create subnets in your required regions. For example, G-Cloud Compute Networks subnets create subnet US Network My VPC region US Central 1 range 10.1.0.0/24. Repeat for other regions as needed. Then create your cloud router in one region. G-Cloud Compute Routers create My Router Network My VPC region US Central 1 ASN 64512. The ASN, or Autonomous System Number, must be from the private range 64512 to 65534. Create the VPN gateway. G-Cloud Compute VPN Gateways create My VPN Gateway Network My VPC region US Central 1. This creates a regional resource that will host your VPN tunnels. Finally, create 2 VPN tunnels for bandwidth aggregation and redundancy. Each tunnel requires its own cloud router interface and BGP peer configuration. The G-Cloud commands for this are quite detailed, involving creating the tunnels, router interfaces, and BGP peers with appropriate IP addresses and peer ASN information. To conclude, let's review the key takeaways from our analysis. After analyzing all the options, option 1 emerges as the best solution. This approach involves creating a VPC with a global dynamic routing mode and subnets in the desired regions. You would then create a cloud router in any region with a subnet, and finally, a cloud VPN with 2 tunnels in the same region as the cloud router. This option successfully meets all requirements. It provides up to 6 gigabits per second of bandwidth with its 2 tunnels, which exceeds the 4.5 gigabits per second requirement. The global routing mode ensures that all VPC subnets are dynamically advertised to the on-premises network. IPsec encryption is included by default with Cloud VPN, and the solution is cost-effective, at around $108 per month. It's also simple to manage, using just one cloud router and VPN gateway. Now for some key exam tips. Remember that cloud VPN tunnels max out at 3 gigabits per second each. Understanding the difference between global versus regional routing mode is crucial for multi-region deployments. Cost-effectiveness will often point to Cloud VPN over dedicated interconnects for smaller bandwidth requirements. And finally, Keep in mind that dynamic routing requires BGP, which in turn requires a cloud router. When you see hybrid connectivity questions, always check three things. First, bandwidth requirements versus the solution's capabilities. Second, the routing mode implications for multi-region setups. And third, cost considerations for the organization size mentioned. Thank you for your attendance. Please consider subscribing to the channel.